surprisingly old and familiar, that's underwhelming. And I consider that a good thing, right? Because it's not forcing you to learn something new or do things radically different. So it's these ideas like, well, we got to be using cloud more to the development and keeping your laptop for what it needs to do, which is to serve your interactive needs. Or this another notion that the master branch should be always a releasable state. That's, again, one of the common best practices that, well, that has been well understood, I think, for the past decade. Or that we need to be deploying often in the small increments, that we should be informing other people about where changes are and what's coming. So all these best practices, once again, are kind of boring, like nothing groundbreaking. The whole idea is that we were able to put all these things together behind very simple to use interfaces, the CLI, and the functioning system all together. And that, I think, is a key value. That, in other words, the value is integrating all these pieces in a smooth surface, as opposed to asking you to put them together. So, the Kubernetes runs on all sorts of clusters. So Jenkins X also supports lots of different multi-cloud environments. So again, that's, I think, another key value prop. I consider that to be another key value prop to Jenkins X. Because in some sense, like when I see what's going on, well, those of you who have been around in the industry long enough, and you see these like three big vendors trying to create highly convenient but the vendor lock-in, like it sort of like it feels like a deja vu all over, right? And I'm originally from Sun Microsystems, where like we tried to build this like a common unifying standard for the middleware. I'm kind of a big believer in not getting locked down into one vendor. So that's another, I think, key value prop. So I talked a little bit about how Jenkins X was supposed to be making things easy and productive, but it's been a little bit abstract. Right? So let me sort of make this a little bit more concrete by sort of trying to walk you through on like what that experience looks and feel like for developers. So imagine like if you have one of these laptops that doesn't need to have anything Jenkins or Jenkins X related, right? So as a developer, like the first thing you need to do is, well, let's say you just need to install Jenkins X, the command line, by using Homebrew. So that's the first two commands. And the third command is basically like a bootstrapping the whole Jenkins X sequence. So you're asking Jenkins X to create a cluster. So just three commands, right? And what happens behind the scene is that that you get all the necessary tools and services deployed on your Kubernetes of your choosing, or the JX create cluster could even create a Kubernetes cluster for you if you don't have one already. And then that includes pieces like Jenkins or the Artifactory or the Monocular. And you might not even heard of some of these names before. And that's kind of my point, right? You don't have to do these things, and you don't have to learn about these things on your own. Like it all gets running for you, pre-wired together to work well. And you also get the staging and production environment and mapped well to the Kubernetes concept like namespaces. And then those are the environments where all your future application would run in. And again, it's a kind of a common standard practice that you have the multiple environments with progressively more stringent requirements to get into and more stable and so on. So with just three commands, you get all this stuff. The next step is, it's time to bring up like one application, right? So one or the other options. If you don't really have anything, you can ask Jenkins X to create a brand new project and give you some skeletons. So JX create Spring is basically asking Jenkins X to give you some plain vanilla Spring Boot applications that run the microservice. Or more likely, you probably have some existing source code repo that you're trying to bring up in this older world of a Jenkins X. So you can just switch to that directory and then run the JX import. And then that basically like prep your repository up for the use and the control under Jenkins X. So when you run this just one command, what happens behind the scene is one, you get the source code, right? So that is if you haven't already. And then two, you get the necessary configuration files and like the necessary stuff to build and deploy and do the continuous delivery. So that includes files like a Jenkins file that's a pipeline definition, or the Docker file that's a packaging definition, or Helm chart that's the deployment controller. Right? Again, you can manually write these things from scratch by you're going to Stack Overflow and cut and paste this line, or like I look at somebody else's repository and then grab those things. But all these things kind of just get done for you with just one command. That's so much more convenient. And then it wires all the necessary services for this new repository. So it even asks you, like allows you to create a repository on GitHub. Create a repository on GitHub for you if you don't have it. Set up the webhook so that every time you change lands, that gets built and deployed and tested. It creates the necessary Jenkins jobs to run the automations. what have you, you get all this stuff that you previously had to do manually, you get it for free. And then it creates an initial release and it gets deployed automatically into staging and all of that just happening from behind this one command. So that's pretty convenient, right? And then the final part is the one that you're going to be probably doing a whole lot often, which is to work on the change. And this really isn't any different from what you're used to. In other words, you check out this Git repository, create a local change, and when you're happy, you create a pull request on the GitHub, and then have that code reviewed, and then merge to the master branch, and then that cycle completes. Now, what Jenkins X adds to it is it doesn't really change any of this stuff, but it adds lots of like automated support around it. It's almost like an exoskeleton that makes you more productive. So one, your PR gets automatically built and tested without doing any of the configuration of the processes. And then the app being discussed in the pull request gets its own, what we call the preview environment, its own copy of the environment where this application is not only reviewable, but it's actually running. So which is very convenient, let's say, if you're making a change asked by a product designer, like looking at the CSS file is one thing, but being able to interact with this app, that'd be a whole new level of the convenience, right? So that's what we can give you. And then when you merge your change, the new master branch also gets automatically built and tested, and then the new version number gets assigned with the corresponding change log, and then it gets deployed to the staging repo. Staging environment. And then finally, if it's a time, for example, let's say to promote this one version of application from staging environment to production, all you have to do is to run this one command, the X promote version, let's say specific version, the target environment to production. So what it does is, remember this is a GitOps, so like it's not like this command is talking to Kubernetes to get the deployment done. What it does is there's a repository on your GitHub repository that captures the state of the system, aka what version of what app is running where. And then this command updates that to ask the system to deploy this new version to the production environment, and that gets created as a pull request on this like a state-of-the-world repository. So if you're in a large organized places, there are a dedicated set of people who are authorized to review this change and merge them. That's a segregation of duty. And then when that merge happens, the corresponding deployment runs in the production. So that's the kind of workflow. Again, shouldn't be any big surprise, but just so much automation happening behind the scene for you without you doing any of the work. I think that makes people so much more productive. All right, so that's a quick intro to Jenkins. And now I'm going to switch gear a little bit and start sort of like, I'm going to embarrass myself by trying to predict the future of CICD, which is like the fool's errand. So I think, so like one key change, so we talked about the Jenkins has been around for a long time. Well, one of the things, surprising things that happened that beyond my expectation is just level of automation, level of workload that the people are putting on these kind of things. Right, so in order to meet this challenge, so increasingly what's happening, I think, is Jenkins is getting used more and more like a sort of like a function as a service style thing, as opposed to one long-running Java process that needs to be maintained forever. So the benefit of doing that is kind of obvious. In other words, like it creates a better scalability isolation for people using Jenkins. And Jenkins X, for example, already uses Jenkins in this manner. So if you're using Jenkins, you probably know these challenges of like plugin versions impacting so many jobs and so on. These are starting to be a thing of the past. So we are kind of upping your game in the Jenkins project. It's not just this user experience around Jenkins X, but also at the fundamental infrastructure level. The other thing I think that's happening in the industry, like if you talk about the future of CI/CD, is that the GitOps is necessary piece, but it is not by itself sufficient to achieve higher velocity while achieving the stability. Right? So I think this is perhaps the area where I think there's a growing realization that we kind of have to create a defense in depth. So the prevailing mindset of the, let's say, previous decade, I think, is that it is the QA that stands between the fat fingers of the developers and fire in production, right? But I think increasingly that's untenable because it creates the slowdown in the velocity. So if you wanted to achieve a velocity beyond certain level, you simply cannot expect the QA to catch all your problems. And instead, what you have to think about is you accept the fact that sometimes the shit hits the fan in production. That's just unavoidable. And instead, think about how to contain those damages or how to detect those problems very quickly and be able to roll back reliably into the safe state. So if you look at the number of the recent practices that our industry has been embracing, a lot of things can be seen from this perspective. So if you think about the feature flags, right? It is a way of you're shipping unreliable, unproven code to the production and being able to conditionally reuse it. And at the first sign of trouble, you'll be able to roll that back without really loading back the deployment, right? That's what the feature flag is. If you think about the circuit breaker, the whole premise of that is some service is going to die and choke up in ways that you can't control. Right? So that allows the operator to redirect the traffic into some other services. So it's a way of letting the whole thing run even though some components are dead. And that's a sort of important engineering practices around tolerating the failures in this growing complexity of the microservices world. Canary deployment is another one example where it accepts the fact that the deployment, a new version might be unstable. The better observability is another business in that regard. Service mesh has lots of technology in this area. Or lately, I noticed that there's this monitoring company called SignalFX that got IPO'd. And I was feeling like, wow, yet another monitoring and observation company. Great, how many more of these we need? And it turned out that their main value prop is that the detection, the time it takes for SignalFX to detect a production problem is in the order of seconds, whereas they claimed previously in some other companies like Datadog, it's in the order of the minutes. And if you think about it, that's kind of amazing. This going down from a 1 minute detection to say 5-second detection is only meaningful if you can recover from these problems in a timely manner, right? If your recovery process is taking 30 minutes to roll back, then going down from 1 minute to 5 seconds doesn't buy you anything. So the fact that they were able to IPO with such incredible price at the valuation is reflective of the fact that how the state of the art has been progressing in the industry, right? So people have been making a lot of progress in this area. And then another growing practice that I'm seeing a lot with success is this the idea of leveraging production traffic. Because let's say, let's face it, developers all know that the test, no matter how much test you run, it's still not sufficient, right? Jenkins, for example, you have amassed more than 18,000 test cases that runs on every single little change, but every time we release it, I'm crossing fingers, at least mentally, and then sometimes it just has a catastrophic impact on our customers. So really, we know that there's nothing like production traffic. So one of the emerging practices is to, let's just reuse this production traffic and statistically test the new version being proposed. And then maybe not this, and just monitor the KPI. In other words, if the numbers that the business cares about is moving into the right direction, it doesn't matter if the program works or, that's by definition, that's what it means that the program is working. So in some sense, the whole idea of testing in this case is replaced by having the right KPI. So this is not to say a test is not important. All I'm saying is we need we need help from every aspect of the software development process. The part of the point of continuous delivery is that now we have a lot more leverage and arsenal and across the software development lifecycle we can use to improve and protect our quality, and then not just the QA. So I think that is the growing realization. Now, so all this stuff is kind of being done, and then we're really cutting edge places that I'm lately very interested in is this idea that once the automation matures to a certain point, and then you start some of these practices, the collective automated system around the software development process start to produce lots of data. And then if you look at those data, there's actually a gold mine that you can use to drive further improvement in your software development efficiencies. And I think that's the emerging frontier of the software development velocity improvements. So one that caught attention is this smarter testing. So mentally picture yourself in this big company, right? And then you're in the DevOps team. So your responsibility is to, your company have several thousand software developers working on this one big code base. It's a one monolithic code base. It's a one big code base, but it's well modularized. So it's a web of dependencies. But it's just because it's so big, it takes a lot of time and money to run tests around them. And in fact, you have so many tests that you can't possibly run all the tests on all the changes. So the question you have is, how can you cut down the cost and time of the software development, right? Because again, your tests, there are so many tests to run. Like you can't just, if you run them all, like it takes like a multiple days, and that's simply not acceptable. So step one, and then this is the, the step one, what they did is if you map out the dependencies, so let's say, so the diamond at the bottom in orange, in the yellow is the files, and then square at the middle is the modules, and then let's say the blue circles at the top are test cases. So what you can do is, well, let's say, if only like the leftmost file has changed, and then from this dependency analysis, you can statically determine that what set of modules need to be rebuilt and what set of tests need to be rerun to verify those changes. Right? So you can imagine that can drive a very significant improvement. And I say it's kind of obvious because this is not what impressed me. But I think it's also worth noting that in most of the teams that I go see, they're not even doing this. Right? Typically, what happens is like every single change anywhere in the system basically triggers the entire recompilation and rerunning of the whole test. That takes 1 or 2 hours, and people are okay with it. So average state of the world is already incredibly bad, to the point that this step one kind of look amazing. But what's truly amazing is they didn't stop there, and then they went to the step two. So what they did was they trained the machine learning model to try to predict the useful subset of the test to run. So based on the changes of the inbound, based on the inbound changes. And again, intuitively, this makes sense, right? Like again, if you're a software developer, you know that if you have changed this part of the system, you probably like most of these tests are not simply like exercising the part that you modified. So you kind of know that's true. What you don't know is like what actual list of tests that should be run. And then that's the kind of thing like a machine learning model can learn from. So because they are the big company, their system was going through 10 to the order of the 5, so that's like 100,000. Am I doing the math right? I think order of 100,000 changes going through the system. So if you just extract 1% of it and a few thousand test cases, that's sufficient to train the interesting model. So the impact that they reported was pretty amazing. So the one that the algorithm only selected like a third of the test, which is different from every one change to the next. And then whenever you run smaller number of tests, the thing that you have to be careful about is maybe you fail to run that one test that actually would have caught the regression. So they monitor that number, and they only reported that by reducing this distance, they only let 0.1% of the broken changes slip through the system. So that's pretty amazing number, basically perfect prediction. And then they were able to cut the cost of infra execution by half. Right? So that's a tremendous saving that can be turned around to hire more developers to do more meaningful work. So in the interest of time, I want to skip the next, another example of the similar kind. But what I was trying to, this kind of really got me thinking. And then in the very beginning, I guess I didn't really call out the fact, but the DORA report, the State of the DevOps report called out the fact that the people who are already moving fast is moving even faster. And then people who are behind the curve seems to be not catching up. The gap is widening, not shortening. And I thought this was a great example of that, right? I mean, for most of us, I think this machine learning-based test selection, it's kind of a science project. It sounds like a good idea, but it doesn't feel like you have so many low-hanging fruits laying around that you don't even get to that point. But some of the companies who actually exist and breathing today are actually getting to the point of tackling these problems. And when they do, it has this tremendous impact of being able to, basically cut the execution down by a third, and then cost by half. And that's a tremendous speed boost, right? And I'm sure. And then so I used to have this mental picture where, and I think this is true with many software developers, that a small elite group of developers can make this incredible impact in ways that a large organization can never do, right? That's sort of like a pride of being a small startup. But wait a minute, if you think about it, if the data is really driving the next generation of productivity improvements, maybe the software engineering is kind of starting to become more mature stage, almost like a manufacturing, where the scale of economy really makes or break the system, makes or break the efficiency. And then, if you think about something like Google, again, Google's aspirational picture, again, part of it is branded, engineering branding, but there's a truth to it that they perfected this internal software development infrastructure to the point that the Google engineers doesn't want to leave Google because they they lose access to this amazing infrastructure. Right? So that's a kind of example where a large organization has achieved incredible software development velocity by using, in no small part, using data, and then that kind of compounds more and more. So, I mean, for me, I'm like a fan of a smaller company, so this starts to feel like a little bit bleak, or a little bit like a bleak dystopian future. But I just like this is something I wonder nowadays. But anyhow, just to wrap up this talk, I started saying that every organization is trying to get better at software delivery, and they're struggling and suffering and trying to figure this out. Kubernetes, I think, is an enabling technology, important building block for that. But I think also a lot of companies are trying to just figure that out. And then that process itself could be a distractor from what's really important, which is to deliver application faster. And then so the right question to ask in my mind is, instead of putting things together on your own, like think about the right developer experience. And I think the industry has pretty convincingly answered that to be the GitOps. And therefore, what we are trying to do in Jenkins X is to give you the prepackaged nice experience around software development process so that you don't have to roll your own. It's going to become a legacy the moment you start creating it. And then finally, like CICD, the practice of that is evolving still after so many years. And then so is Jenkins to kind of keep up the game. But I hope some of you find some of this, the trend that I'm observing interesting and thought-provoking. So on that note, I wanted to end my presentation. So thank you very much for your attention.